Chirija, and good evening. My name is Madrina Chirija, and together with Tai Sejin, we're going to take you through the EDA of our project. Yes, and we're going to start by understanding what EDA actually means. Well, EDA is a process of analyzing and summarizing a data set to understand the structure, the pattern, and the characteristics. So when we are trying to look at our data sets, because we're going to use, remember in machine learning, the model to learn from patterns. And when it's learning from patterns, it's basing on data sets. That's the data that we get from it. So when before we give it, we feed it to the data sets and everything, we carry out EDA, that's explanatory data analysis. And this is a process where we try to understand the patterns, the characteristics, the structure, and all that, based on our data. EDA has steps, and we have inspection, data cleaning, descriptive statistics, data visualization, feature engineering. So the first thing that you always have to do in a data set when you're trying to explore your data set is data inspection. Under data inspection, we are looking at finding out if the data actually be missing data, the data characteristics, and all that. And then we also look at, when we move on to data cleaning. So in case we carried out an inspection and realized that the data has maybe missing values, like 2 missing values or something of sort, we're supposed to clean that data so that we provide that system, the model, with clean data that it's going to train from. Then we have descriptive statistics that we shall show you. You can choose to represent your things in bar charts, histogram, like when you're trying to study your model, all that. And then there is visualization, where you'll use maybe graphs and all that. And then we have feature engineering. Feature engineering is providing additional information. For example, if you try in feature engineering, mainly, we tend to break down, like, for example, statements and words into tokens so that it can at least analyze it the way we told it to. So in our presentation, we're mainly going to focus on the parts of distribution of questions, because in this system, we're trying to make sure that we train the model to understand the questions that people are going to ask, the answers they can give, and all that. So we're going to look at how the questions and answers are distributed, the most common words. We're going to look at the question types, the distribution according to numeric answers. We're going to look at the length versus answer length. We're going to look at the TF, IDF for keyword extraction, and we're also going to look at the answer length based on the mathematical operations. So in this code, we begin by importing files, we begin by importing libraries that are going to be beneficial. First, we import Panda to manipulate. It's used in manipulation and analysis. Then we import JSON lines, whereby JSON lines is going to help us read JSON files, because the data sets that we are using are they are written in JSON. So this library is going to help us interpret those files. And then we import MATLAB and Seaborn. These ones are used for data visualization. So when this is going to help us from. Then we also import word cloud, which generates word clouds from text data. We also import NLTK, which is a natural language toolkit for processing. We also import RE, which is regular expressions for finding out the next pattern, text pattern matchings. And then we also import the TF, IDF vectorizer for feature extraction technique, text data. So when we start off with this, we are going to start with the first part in the data set and all that. Could you please scroll up a bit? Up. So in this, the upper part talks about we open the data set and read the data, and then line by line. So doing this, we are trying to find out if there are to find out the data types and also discover the missing values. So when we run this code in the terminal, we get to realize that there are no missing values. and we get to know the different data types that we're working with. So if there were missing values, that's when we would have to carry out the data cleaning bit. Yes. And then after that, we carry out what we call feature engineering. Carrying out feature engineering is more like breaking down a word into tokens so that the system can see how best to learn the patterns and get to understand it. So for example, if you have something like, how much do you have? A statement, they'll try to patterns like how much alone, so that you can have 5. So that one sentence becomes 5 words. So that's what happens in feature engineering. And when we move on to the descriptive statistics and data visualization, the first thing that we're going to look at, we are looking at visualizing, we are looking at the distribution of questions and answer length. So in this case, the model, we're trying to break down we're going to look at how long the question is and how long the answer is. So we try to plot a histogram of how the question is, the length of the question versus the length of the answers. This is going to help us, as shown here, this is going to help us know that maybe if the question is 50 words long, we expect the answer to lie in maybe 80 words. You get what I'm saying? So that's this main part does in the visualizing bit. Then in the next part, we talk about the categorizing based on the mathematical problems. And the mathematical operations, that's addition, subtraction. Yes, that's addition, subtraction, multiplication, division, and others. Well, here we're going to look at a question and analyze it. The model looks at a question and analyzes it. When it analyzes it, it categorizes it in terms of, it's going to categorize it in terms of, this is an addition question, this is a division question, this is a multiplication question. Yes, and then the other part that we look at, we're looking at categorizing based on the most common words. So here we look at, it analyzes all data sets that we, and then it picks up the questions. Picking the word are most common helps it understand, and it maybe finds out how much are the most words. So that one maybe gives it an idea that it's trying to value how, so based on the code that is written, discover what are the most common words in the questions. Yes, I'll hand over to the next speaker to take you through the remaining parts that you're trying to analyze in the EDA. Thank you.
Good evening, everyone. I'm going to be taking you through the remainder of this exploratory data analysis. So, continuing from where she stopped, she talked about categorizing questions based on the operations of the mathematics. Since we are dealing with data sets that handle elementary mathematics, we are looking at the 4 basic calculations, that is addition, subtraction, multiplication, and division. So, to begin with, we categorize all these questions and answers based on these operations. However, not all the questions are going to be phrased with these keywords. For example, in addition, we have the word add, sum, plus, or even the plus sign. Then we know this is an addition question. For subtraction, we have subtract, minus, difference, or the minus sign. We know this subtraction, and so on. However, most of these questions will not have these keywords that will be able to be easily identified as either a subtraction or division. So we are going to categorize them as other. This will help us in training the model and to see whether we can train it to recognize these questions and maybe put them in better and put them in those categories. Then we are going to see the analysis of the categorization. So we are basically going to see how many, you're going to see how many of these questions lie where. So as we can see, most of the questions lie in the other category. So they don't lie under subtraction or division or multiplication or addition. So this will help us when we are training our model to see what we can do about this other category. Then from there, we are also going to see the distribution of numeric answers. So we are going to check our models and see where most of the answers lie. Are they lying in the hundreds? Are they lying between 0 and 100? So first we have to extract these numeric answers from the text. The data set we're handling is basically a what I can call word problems in mathematics. So it gives us sentences with some hidden math calculations which the student has to decode and calculate and get answers from. So as we can see, we first categorize these answers and then we develop a pie chart that will help us visualize this. So from this, we can see that we have a distribution from 0 to 10, 10 to 50, 50 to 100, and 100 plus. So from this pie chart, we know that most of the answers are going to lie between 10 and 50. Then the second largest, maybe the values or the answers will be increasing to 100 plus. So from this, we can now, when we are training the model, this will help us to gauge based on the, maybe, since we're doing elementary mathematics, maybe gauge based on the child's experience. So we shall first start with fewer questions which will require smaller numbers. Then over time, we will be upgrading based on whatever model we shall be training and the GPTs to use. Then from there, we are going to carry out multivariate analysis. So we have been handling univariate analysis where we are dealing with one feature or one variable. Now we are going to see the comparison between various variables in our dataset. So since we are dealing with question answer type of dataset, we are going to see the comparison between the question length and the answer length. So to begin with, we are going to create a scatter plot. Now the scatter plot will help us to gauge how these questions and answers are related to each other. So we can see that most of these question and answer lengths lie between about 15 to around 95 words in length, and most of the answers lie between 1 and up to 200 words in length. So you can see that the furthest or the largest question in terms of words is around 180. However, that question has an answer that reaches around almost 200. So this will help us in creating a model that when you ask a question based on a certain length, we expect the answer to also give us its correlating answer length. So that is that. Then from there, we are going to do an advanced analysis using a TF-IDF analyzer, which is going to help us in key extraction. So we are going to use a TF-IDF vectorizer, which we get from a package called scikit-learn, and it's going to help us in feature vectorization. So basically what this helps us is this TF-IDF basically is a text feature and inverse document feature. So this helps us in things like keyword extraction, or when we are dealing with analyzing words or text. We are going to see what is the importance of a word in response to that question. So we are going to see what is the importance of this word in this question. So when a prompt comes in, for example, we are dealing with mathematics. In mathematics, we know that if I see the word sum, we know it's going to help us in doing addition. So coming up, we are going to come up with a bar graph that will visualize this for us. So we can see the word that is really important. The most important is the word does, and the least important is the word bot. So when you're training our model, it's going to help us know that, okay, when I see this question, I'm going to look for the keywords and will help me figure out and create an appropriate answer for the student. Then from there, we are going to see the answer length. We are going to see the answer length by question category. So basically what this does, we are going to analyze based on whether it's addition, subtraction, multiplication, or uh, or division. We are going to see how big are the answers going to be depending on the operation that the student is working on. So the chart here is here. So we are going to use a box plot that is going to help us in the answer length. So for example, we have subtraction, division, multiplication, addition, and other. Since addition, there are few, we are going to see the fewest strings here, but you can see that the addition questions reach around 250 in answer length. However, subtraction reaches the highest of about 300 in answer length. Then multiplication, you see that it reaches the highest of its highest is 258. So this will help us when you're creating a model to realize that if this child is asking a question related to subtraction, it's going to help us to determine how much the answer should look like or how long the answer will be for the student to understand. And then lastly, we are going to compare dataset sizes. So we have 4 datasets, namely train.json, test.json, and then train Socratic and test Socratic. So the Socratic files these are models that first think before giving an answer. The train and test.json files just have files that have question and then immediately give you an answer. But Socratic files have a question and then a thought process that will be first read before giving an answer. So to visualize that, we are going to see it in terms of a bar graph. And from here, we know that the train dataset have more words or they have more data in contrast to the test and the test Socratic. So there you have it. Thank you for listening.